Okay, so in this video we're going to review over polyatomic ionic compounds. Alright, so first, polyatomic ionic compounds, what are they? They are compounds that contain a polyatomic ion. They are ternary compounds that have 3 elements in them, or sometimes 4. So to tell, I would always need to look and see, first always tell, is it ionic or covalent? If a compound is covalent, I'm using prefixes to tell the number of atoms. If it's ionic, I'm using the rules for naming ionic compounds, so just name the metal, name the non-metal, drop the ending and add IDE, or name the metal and name the polyatomic ion and leave the name alone. Alright, so if I determine it's ionic, then I check and see if it has a polyatomic ion. So this first example, I look at the first element. I notice first that it has a metal in it, so I know it's ionic. And then I look and it has 3 elements. It has sodium, nitrogen, and oxygen. So it has to have a polyatomic ion. 90% of the time, it's going to be this second 2 elements. It's going to be the formula of the polyatomic ion, unless it's the ammonium ion, which comes as the first because it acts like a cation, which is NH4. But if I look, I'm going to name the metal. Na is sodium. I'm going to name the polyatomic ion then. NO3, if I look it up on my chart, the formula NO3 is the nitrate ion, so it's sodium nitrate. I do not do nothing to the ending. The way that I, if we have this compound here, that's a binary compound. I would name the metal in this case, which is sodium. And then I name the non-metal, drop the ending at IDE, that would be sodium nitride. So those are 2 different compounds. The binary compound, like this one, I drop the ending at IDE. With the ternary compound, the one with the polyatomic ion in it, I just name the polyatomic ion and I don't change anything about it. Alright, this bottom example, I look, first element's metal, so I know it's an ionic compound. And since it's got this in parentheses, I should automatically know that's a polyatomic ion right there. And this number here, this 2, is just telling me that I have 2 of these ions. If I had a phosphorus bonded to 4 oxygens, and what it was telling me is that I have 2 of these ions. And they would be bonded to 3, barium atoms. But when I name this is barium. And PO4 is the formula for the phosphate ion. So the name would be barium phosphate. Now let's look at writing formulas. Well, this is first example, cobalt 2 sulfite. First, again, I always want to look at the first element, see if it's a metal or non-metal. It is a metal, so I'm going to use the rules for writing formulas for ionic compounds. And this 2 here, what does that tell me? Well, it's telling me the oxidation number of the metal, and metals always have positive oxidation numbers. It's telling me it's a positive 2. Alright, so cobalt symbol is CO, and it's telling me it's a positive 2. Sulfite. Now, if this would have said sulfide, IDE, I knew it was just talking about sulfur. But sulfite and IT is a polyatomic ion. I look up this formula, and it is SO3, and it has a -2 charge. If these charges add up to 0, plus 2 plus -2 does equal 0, I just cancel the charges out and write the formula. And that would be CO and then SO3. It takes just 1 of each, just 1 cobalt and then 1 SO3 ion to balance the charge, and that would be the formula. Now the bottom one, I look at the first element, zinc. It is a metal. left of the stair-step line, so this has to be an ionic compound. Next I want to look, is it talking about a single nonmetal? And since the ending is ATE, it must be a polyatomic ion. It doesn't end in IDE. So this would, I would write the formula Zn, and I remember Zn is always a positive 2. And then phosphate, if I look up its formula, my list is PO4, and it's a -3. If these numbers are different, I can do it, one of two ways. I can say, well, +2 and -3, I gotta look at the least common multiple, which would be 6. I need a +6 on there, and I need a -6 for those to add up to 0. So for zinc, that means I would need 2 more +2 ions to add up to +6. For phosphate, I would need to add 1 more phosphate ion that has a -3 charge. Those would add up to -6. And then I would write my formula. It would be Zn3, and then PO4. But since I have more than one of them, I would need to put the formula in parentheses and put the 2 on the outside. Or my other method is to cross my charges if they don't add up to 0. I would need to cancel out the positive and minus, bring the 2 down here, bring the 3 down here, and then write my formula, Zn3, and then PO4, but since I'm bringing a number greater than 1 down, I need to put PO4 in parentheses and put a 2 on the outside. That would be the correct formula. Now for your worksheet that you're starting on, first page has a chart like this, and what you're doing is you're taking like sodium is in the first row here, and you're going to bond sodium first with SO4 -2, the sulfate ion, and then with NO3 -1, and then when you bond it, you're going to name it. So I need to write the formula first. So when I work the first row with you, sodium bonds with SO4 -2, and the formula, you might have to get some scratch paper to work these out, but the formula, when I cross my numbers, I'd end up with a formula of Na2 SO4, and that would be, I'm going to name it then, Na is sodium sulfate. Next, Na +1, NO3 -1, the ones would cancel each other out. I just write the formula Na, NO3, so that would be sodium nitrate. NO3 is the nitrate ion. Next, Na +1 and PO4 -3. When I cross those charges, it becomes Na3 PO4. I name it, that is sodium. PO4 is the phosphate ion. So sodium phosphate. Just a few more. Na +1 with bonds with CO3 -2. When I cross them, I get Na2 CO3, sodium carbonate. Next, Na +1 and SO3 -2 gives me Na2 SO3, which is sodium sulfate. And then last, Na plus 1 and NO2 minus 1 would give me Na NO2, and that is sodium nitrite. So now you'll go and start with magnesium and do the same thing. Magnesium with sulfate, magnesium with nitrate, magnesium with, PO4 minus 3, and then on with the next ones.